the final demo, which is about this TcpServer library. So I think it was like 2 or 3 sprint demos ago we demonstrated this the first time, but maybe some of you missed it, so I will do a small repetition. So under the HCL RTist account on GitHub, we have some libraries and some examples. And one of the libraries we have there is libTcpServer, which basically is a library that allows you to put into RSIRT for communicating with TCP with other applications. And in this, it works by actually, first you create a subcapsule that inherits from this library capsule called TcpServer, and then you add a part to your composite structure typed by that subcapsule. And then that basically has a small TcpServer which allows an outside application to send commands to the application in order to, for example, send events on the ports on this capsule and invoke events and do some other things also. And one thing that was missing before was to be able to reply on invokes. So assuming that this capsule here would, it could invoke on this traffic light here, but if the traffic light would perform an invoke that would go to the TcpServer, that would previously not be possible to reply to, and the application would stop. So in this sprint, we improve that by supporting an additional command called reply. So if the remote application wants to make a reply on an invoked event, it can send back a JSON string to the response of the TCP request. And in that case, the command should be set to reply. The port is the port, of course, where he wants to do the reply. The event is the event to use for the reply. And if there is any data with that event, it can be specified as usual, the data, and then the ASCII decoding of the event, ASCII encoding of the data object. And also to note is that any event that is reached by the external application should be responded to make the TCP request complete. And the way you can do it if you don't have any data to reply back is simply to reply with an empty JSON string. So here is a slide that shows a bit the bigger picture here. So we have an application generated by RSIRT that has one, possibly many, but typically one, this TCP capsule that is able to receive these commands. Then we have some external application, and this could be a test application. It could also be another application generated by RSIRT. So you could build distributed applications this way. So here, for example, you see an example where we have generated 2 RT applications, each of them having one TcpServer, and since is completely symmetric, it means that everything that goes out from application 1 can be handled by application 2 and vice versa. And this was now also complete since we have this possibility to reply on invokes, meaning that application 1 can perform a remote invoke to application 2, which it then can reply back on. So some of you saw when we went to the conference, IoT conference in Germany in February, and also I think we talked about the Tech Connect. We have a game application that we developed for the purpose of conferences like that. And the one question that we looked at in this sprint is how could we test such an application using this TcpServer library? And to the left you see what this game capsule looked like originally. So it had a camera, an image recognizer, a push button, and it had 2 capsules representing incoming and outgoing communication to a web server. And assume now that we want to do some testing scenarios, and we introduce a test driver capsule, which inherits from this TCP server capsule that I talked about in the library. Then we can reconnect the connectors here. So for example, in case we do not want to have a real camera in the test, but we want to let the test driver play the role of the camera, we can simply reconnect this connector between the game and camera port to now go from the camera to the test port on the test driver instead. This means that the test driver now can play the role of the camera, and when the game asks the camera to take a photo, the test driver can reply back and say, yes, here we have a photo, and it can give it a test photo used for this particular test. And the same situation is exactly the same here for the web server, where we can mock it out by rerouting the connector to go to the test driver instead. For image recognizer, we have a slightly different. It's not enough to just mock it out and to let the test driver play its role, but we actually want to use the real image recognizer, but we want to be able to check all messages that pass through the connector between the game and the image recognizer here, this connector. And the way that can be done is that you can add ports on the test driver so that all traffic flows through the test driver. This means that you can then, your test case can then check so that messages are look as expected before you forward them on to the image recognizer and vice versa. So once you've done this, you're ready to start writing some tests. And it can be done, of course, in any language that supports TCP-based communication. So basically, you can use anything. But something we've looked a bit into is something called Node-RED. One reason why this is interesting is that it's low-code solution. So it means that you can actually do quite much without coding anything. So you don't need to know, for example, how to code C++ in order to test this application. Yeah, so I will come back to that later now when I'm going to the demo. So let's look at this in the real life, what it looks like. So here we have our game composite structure that I showed you in the screenshot. And for example, if we look at this camera port here, we see that the type of this is camera events protocol, and it has this take photo. So the game can ask the camera to take a photo, and the camera is supposed to respond back with an image file name, giving the name to the photo that it took. And this is a synchronous event, so this is done by invocation by the game application. So now if we look at Node-RED test case here, we can see that how it can be implemented. So basically, the first upper 4 nodes here you see in the flow is what basically triggers the test to start. So first we send the start game event, and this node here is a special node for RCRT and RTist that is available. But it can also be done, of course, with a regular TCP request node that is available in Node-RED. So, but here is slightly more simple because you just need to specify which event I want to send to my RT application, which port do I want to send it to, and then, of course, you need to specify here where the application is running. And you could give priority in case you want to do that. So here we send the start game, which will make the game start. And then we wait 5 seconds, and then we send another event, which is called done drawing. This is the same as if the user presses the button saying that now I have drawn a picture in 5 seconds, so please analyze it. The rest of the test case that you see down here is actually what sets the verdict, that checks that we got the expected communication in the application. And first thing is that we have this TCP node that allows us to receive events coming from the RT application. And it's a JSON format, as I said, so we can use this JSON node to parse it, and then we can use a switch node to check for some kinds of messages. For example, we want to check the take photo, the analyze image, and the result events. And we draw one wire out of each of these ports here, and we do something with them. So the first case is the take photo. That was the one I showed you previously. So when we get that, we want to respond back with the image file name and make a reply. And this is what is new in this sprint. Now you can just create this message here in JSON. So command reply and set everything up here. And here you see as data, I specify a file path to a local image on my local file system. And then when you have done that, you simply give that to the TCP reply node, which is a built-in node in Node-RED, and that data will come back then to the Arch application. Same thing for the next one, the analyze image. So when we get the analyze image, and here, if we switch back here, you see that this is something that the image recognizer port here can send to the image recognizer capsule. But since we have now introduced this extra level of indirection, we need to make sure that everything that arrives on the IR in port is forwarded to the IR out port and vice versa. So here we simply swap the ports. So we set the new port with the IR out. And then since the protocol is completely symmetrical, we don't need to change anything. We can just parse that or create a string out of the JSON exactly as this. And then we need to reply to the TCP request. And in this case, it's an event, so there is no invocation going on. We can just reply with an empty JSON object. So we route the first up here is the outgoing text string that we send to the application, and then we send the empty JSON object back to it to let it continue. And for the result, it's very similar, but here the result is opposite. So here we get the result from the image recognizer, where it has tried to guess what image that my photo should look like. And it's sent here to the test driver, so we need to check that it is as expected, and then we need to forward it out to IR in to let the application continue. So it's very similar to the previous one, but here we now set the port to IR in. We then know that our test photo depicts an apple, so we want to make sure that the image recognizer is able to tell that it is an apple. And then we do exactly as before, but this time we also have a test verdict, which we simply will print to our debug console here. And for this one I will skip for now. So I have built this application that I showed you, and let's start it and attach to it. So now it's running here on my local host, and I can attach the model debugger to it so we can see what happens. So we have two state instance diagrams. The one to the right is the main one. So first we will go into, I can start the game here. So you see that now it's in the wait for new game. Waiting for the user to push the button, or in this case, the test case, to give that event. And when it happens, we should see that it will transition to the drawing word state, which is a composite state. So it should then go in wait for drawing. It will analyze the drawing when we push the button again, and then we will see if the test case can pass or fail. So now I need to go here, and it's a bit shorter screen, so hopefully, I'm not sure if you can see everything at the same time. Maybe like this. So now I will trigger the test case manually by pressing this button here. And you can see now the applications went into the drawing word. It waits 5 seconds. It tried to guess it, and then it will eventually wait 15 more seconds until it will finish that game. But actually the last part is not so interesting, because already now we have got the pass verdict for our test case, because we were able to conclude that what we passed to this image recognizer was looking like an apple. Another thing we did improve in this sprint is the ability to so you can see there, to handle events in the application itself. So sometimes you want not to pass all events out to capsules in your application, but you may want to handle them yourself in the test driver. So we added this possibility to have an extra flag in this syntax, and it's called incoming event. So if this is a new property that we added in this sprint. So if you set that to true, the event will not be routed out to any out outward capsule here, but it will be stay inside this test drive capsule and can be handled by each state machine. So for example, in this case, if we open a state machine, we see that we handle one event here called dump all. And it will simply just dump some metric that I collected while running this application to a file. And then when you've done that, it's easy, for example, in Node-RED to just have one extra node here where you can send that event into the application. So pressing here, and we should see here now we got print out that the application received the event and it dumped it to a file. So I think that was mostly it. Any questions on this?